3, 2, 1. Hello. Welcome back to the program. We are continuing the development of the new image recognizer, Gazelle 22. The weather is dark and a little cold, and cryptocurrencies are not that good right now. Well, I'm mainly watching Monero, because recently I made 6% profit in 5 days, which I think is actually kind of extremely good. The question is whether that's repeatable, or how often it is repeatable. So let's see. Probably need this view. Yeah, so there was ample opportunity to make money between here and here. I don't recall exactly when I bought and sold, but I think a general algorithm could actually be made to trade automatically. So right now we have to wait for, the curve to go up. That's a requirement to make any money. I'm not even staking right now. I should stake again. And I bought some Luna too. Luna, the horror coin. I also bought some Luna just after, when it was already crashing, but just for €2, just for fun. So that Luna investment did not help us much. Oh, what is this? Luna Innovations, that's something else. So Luna is the coin we all know went to the bottom and is not going to recover. I mean, basic algebra tells you it's not going to recover because there are just way too many Lunas out there. But Do Kwon has actually made a new currency just a few days ago. And I mean, should we trust this guy again? Should we trust him again? He just botched one coin and now he's made another one. But I bought some Luna too because I mean I can still buy his coin even though I think he's not the most trustworthy guy. Yeah, so it's just like 1 day old or 2 days old, this currency. Yeah, right now we are on this flat line here. But I bought it today, and if I had sold it like an hour later, I'd already make like more than 10% profit, I think. Minus fees, around 10% maybe. It's actually kind of easy to make money with cryptocurrency. Yeah, check this out. Buy the dip, $3.93. $6.19. I mean, it's super easy to make money off this distance. The only question is, will coins crash or will they not crash? So the scheme I'm proposing is not risk-free, but you can manage your risks absolutely by only reinvesting a part, and etc. So let's see how this will continue. It'd be so funny if I had an automatic trading bot. I was opposed to this kind of concept, actually. I thought it was just too much speculation, but I think this can work, actually. Alright, so back to the topic. Thinning. What is thinning? Thinning in Gazelle refers to excuse me, this process. We have some kind of shape, and we thin it down to something that should be only 1 pixel thick at every point. And then we can do something like this, where we mark all the ends of all the lines and all the intersection points. And I made an algorithm to do this thinning, but it's still a little bit broken. It sometimes splits the structure in two where it shouldn't. So it's not completely perfect. And I thought, what is thinning? Thinning is actually basically the opposite of something else, which is growing a shape. I think embossing. No, embossing is something else. Graphics programs may have different names for this. But basically, yeah, let's define some shape to start with. Here I have this nice way of making images from a function. So how do we define, let's say, a How about a circle? Which is actually not trivial in this kind of representation. Or you could just draw a circle. Well, let's make like a little square. So what's a square? Let's start with this. That's not a square. And let's put a knot in front of the whole thing so it gets inverted like this. So what do we got? We have yes, we have two vertical lines, and we have that doesn't work yet. Yeah, my scripting language could see some more improvements, for sure. What did I do now? Okay, this, but that's obviously not correct yet. What is the simplest way to define this boundary in one function? You could actually take like the filled square and subtract from that the white part inside. That would be one version, or we just say, yeah, we define each of these, each of the four sides. So let's put some variables in. 2040, and the same thing. So the left line is x equals x1, and y is between y1 and y2. That looks pretty good. And then we have, oh yeah, in fact we can do both of the vertical sides like this. There we go. And basically the same thing with swapped coordinates. Like this, and there it is, all square. Thanks for watching. That's it. Goodbye. No. But it's worth a screenshot. Okay, there is our original image, and we can actually save it to our project. Square. And now we could try the growing, making this line thicker. So we get our image. Oh, let's save this. Save the script. Oh, there's a problem that sometimes dialogues are shown in the background instead of the foreground. Here, that's my. Okay, draw square. Yeah, one of the bugs to be fixed. So we get our gallery image, which has the. No, in fact, we can just load the image file. Load image 2. It's 2 because reasons. Project file. No, project file. Square.png. Yes. Okay, that's our image. We convert it to a black and white image, which looks the same, obviously. And then we go through all the pixels. Yeah, let's grab the size. And if we just replicated the original picture, we would say image get pixel xy. Yes, that still gives us the same image. But now we want to grow the pixels. We can actually grow like in all directions at once, 1 pixel at a time, or we can grow in just one direction, like right, down, left, or up, which I think is a nice like breakdown, nice simplification of the process. Because in that case, we only have to look at 2 pixels per output pixel. So we are operating on booleans here, so this is a boolean. Basically, we could say image get pixel x plus 1. Oh, by the way, I'm working on something that makes you able to say not plus x1, which is a little intuitive, but actually x plus 1. Which is a little better. It's still not this, but it's more readable. That's not workable though. Yeah, it's not working yet. So anyway, plus x1, I think this may cause a problem. Because what if the pixel is outside of the image? Let's just try actually. Yeah, it's almost, I mean, it creates a spurious black pixel down there. We could just make a smart method that provides a default color when it's outside of the image. Yeah, that's actually pretty smart. I think we should add that. So we have get pixel here, and let's just put a default, user-defined default in there. Default color. Yes. So our boolean is now a color, meaning white is true and black is false. So if we are outside of the image, we return the default color. Otherwise, we call the normal get pixel method, and a little comment is maybe in order. Default color is color outside of image. X and Y must be inside the image. And probably we have to recompile the whole project, sadly. Yeah, it seems like we do have to do that. Let's just get over it and do it. I do have some smoothie, actual healthy drink, I guess. The other point on the goals list is to track some actual things, like my headphones. In the image, I have some ideas for that. In the video, I should say, not only the image. And finally, we will improve the Gazelle UI along the way. The handling of these networks can see some improvement. Make it more productive, intuitive, and powerful. Yeah, so the gears are turning, it is compiling. It looks like it's 2 pixels wide. Am I dreaming? It can't be, actually. Why does it look like it's... No. It's my monitor. My monitor is squashing things a little bit. It's funny, I don't really know why. It's neither 16:9 nor 16:10, I think. Something in between or so. I literally didn't find a resolution that makes pixels square. I'd only found a compromise. Otherwise, it's a nice monitor. So I think repackage is what we have to do. Yes, now it should restart. Yes, no, maybe. Yes, it does. Come on. There. We want to use the version with the default. The default in this case is true for white. Yep, there we go. Black pixel disappeared. And yeah, oh yeah, of course it's wider. I just applied the grow procedure, which makes 1 pixel into 2 pixels in the x direction. And then I complain, why is it wider in the x direction? Like I'm really the smartest guy alive. Okay, so this is thinning to the right. We could generally define a direction, so if we have dx equals 0 and dy equals 1, we would grow downwards 1 pixel plus x dx plus y dy, and there we go. And if we had something like 1, 1, we would grow diagonally. Yeah, that's actually quite cool. I think this warrants being put into a Java function, because Java functions are still faster than functions made in my scripting language. However, that's going to change eventually. There's no reason why my scripting language should be any slower than compiled Java code, and in fact it will be as fast when I get around to it. So, what's a good name for this function? Grow black. Needs to be black. It's like, it's not a good name, but it's I can't spend all my time thinking about names. So we have the image, and we have the dx and the dy. And we just need to do the conversion to Java. Almost there. Here, true, and there. Image to be grow black. I ordered a new silent keyboard from the eBay. It should be in the mail like the next week. Because this one is actually kind of loud. Okay, let's try the new function. Yes, add to Gazelle. What are our parameters? Our parameters are these. Oh, this was fast. This is a fast compile. I have the slow compile, which recompiles the whole project, and the fast compile, which recompiles the stuff that usually are not changing, or new functions that I add. And as you saw, the fast compile is actually pretty fast. Just a few seconds, basically. Okay, this one we can probably close for now. And there we go, there's our fast function. Yeah, so yeah, let's do the grow in all directions. I think 4 directions should be enough. So we could do it sequentially or on the same image. Sequentially is maybe leading to some artifacts. Let's try sequential maybe. So for dx, okay, for direction in some directions. One zero, 0 1, minus 1 0, 0 minus 1. Wait for the restart. I have not found a way to add functions to the system while it is running. To add a Java function, I need to restart this program. So, direction X, no, actually A, direction B, and let's see. Yeah, I mean, okay. In this case, I don't see any artifacts. It has made us a thicker square, and it should actually be 3 pixels wide because we're growing it to the right and then to the left, which is a total of 3. Could in fact, without any further effort, show us all the steps. That's the elegance of my scripting language. If we have a for loop, it will actually record all the values calculated and return them. So here is the growing in 4 steps. Grow in 4 directions. Sequential. An I, right? Total blackout. Sequentially, right? Okay, cool. That's that. Yeah, so now what is thinning? We take this last image. Let's save that one also. Run again. I didn't even have to do that. The system is so good. I can just click on this here and save it also. Square thickened. So let's work on this one and try to get to the thinner version again. 50. Here. So it's a logic puzzle. Given this image, what could have been the input image before it was thickened? So I haven't actually thought this through completely, just like no. I thought about it a little bit, and it's going to be interesting to fill the gaps. You know, we'll see. We'll figure this out mathematically. Let's take this other one that just has 1 thickening. Yes. So we go to every pixel and we can derive information. If a pixel is white, remember that for the thickening we always combine 2 pixels. We combine a pixel and its right neighbor, and we do the AND operation, which means the result is black if one of them is black, at least one of them is black. So for every pixel in the result image, if it is white, we know that this pixel and the right pixel, pixel right of it, are both white, because otherwise this pixel in the image would be black. So from a white pixel, yeah, that's right. So white pixel means xy and x plus 1y are white. Or let's say were white in the original image. Black pixel means at least one of xy and x plus 1y were black. Oh, I got these automatic stars here. Wow. Black. So in original image. So we end up with, I think, 3 possible states for a pixel. One state is definitely white. That's when this here applies. The other state for a pixel is possibly black, which means either the pixel is black or the pixel right to it or left to it is black. And is there a third state, which means I don't know anything? Probably not, because every pixel will be touched once. So it seems there are only 2 states, not 3. Right? I thought I had 3 states to work with. Not sure. Okay, let's see. Well, yeah, no, but we have a combined state. One pixel could be in both these categories. One pixel could both be known to be white and possibly be black. But in this case, of course, we know that it's actually white, because definitely beats possibly. So these are the 3 states. Known white, possibly black, or white, or yeah. No, we still have only 2 states, because this one up here overrides this one down here. The only remaining question is, what do we initialize our array with? What is a pixel in the beginning? So it seems to me we have 3 states for each pixel. Unknown, possibly black, definitely white. Yeah. Let's work with these. Let's say we give them numbers 0, 1, 2. Okay, so we have an array. Oh, in fact, I don't know how to make arrays in my scripting language, but we can represent the whole thing as an image. So let's say we actually do this, and so it turns out black, gray, and white. H2 new white image. It starts black. That's okay, because this means they're all unknown. Now we go through all the pixels. And check out the original value. If it's a white pixel, then this applies. So image set pixel, image 2 set pixel xy 255, and then we need the function that is tolerant to out of bounds inputs. Sure. How tolerant is this function? Set pixel calling set byte, and it actually checks for being inside the right coordinates. That's good. So we can just call it any values. Okay, let's see where that gets us. We should definitely show both of these. So, yeah, actually this is already the solution in this case. Is that all? I don't know. I think there are cases where this will fail. Right now, with this simple procedure, we already have the right result. Interesting. So, what is this weird indent? Oh, it came from this comment. It's completely broken indent here. That's better. No. Oh god. Oh my god, my Asperger's. Oh, this is better. So here, yeah. So let's make a function of it. Def thin image. Same result as expected. But what if we do this again? Oh, actually, you want an input here. And to be precise, do this also. What if we do it again? Image 3. Oh yeah, we should convert to convert to the Boolean image. Oh, there's not a function for it. Simple conversion function missing. Let's put it in. Just some boilerplate code. Some shortcut and some other standard conversions. Yeah, I think that could do it. Fix one more mistake here. There. Bam. That function. Yep. So then we will find out what thinning twice will do to this image, because I think it will just erase these sides here. We'll see in a moment. That's pretty good. Kiwi and orange and banana. I'm so fortunate being able to afford smoothies. Yeah, see, exactly as I told you. It erases too much, because we need to honor this also. If white, blah blah, else it's black, so then we have possibly black. I mean, isn't every pixel, wait, possibly black in the beginning? No, actually it isn't. No. No, I think we definitely need these three different states. So now we look at these two pixels again, but we check what's already there. If it's definitely white, we keep it that way. If it's unknown, we turn it to possibly black. That's the only change we have to do. If the value is 0, then we set this to possibly black. And we do the same thing for the other pixel. And let's see where that gets us. Not really any further. Why not? Oh yeah, okay. Okay, the thing is, okay. We were working under the assumption that, oh, this is a bad zoom. That this image is the result of a growing operation, but it's not. There's no way to grow an image horizontally and getting this result. So this result is outside of our assumptions. But I want to do something in this case that preserves the integrity of just the shape. So in this special case, I actually violate this here. So basically, I want to honor the black people. Honor the black people. Black Lives Matter. Honor the black pixel more than the white pixel in this instance. So if something is a pixel black, like if there's no other black pixels around, it needs to stay like that way, so we don't lose structural information. I'm beginning to question this whole approach. I thought it was super smart, as I just find out my assumptions are not really working for the approach. But let's keep going and see if it can be redeemed. Yeah, basically we were doing the white thing first, and then the pixel is already set white. What if we do the, okay. That's why I originally proposed more states. Let's say we have all combinations of these. So we have 4 states. Let's say maybe this, we just do like a combination, like 2 bits. This is the combination possibly plus differently, right? So we do something else. 4 pixel match XY value. So we have 2 bits per pixel now, and we can set each of these bits individually. So v bit or v and value, image set pixel xy, so combination. Oh, we should have type information in method signatures. Do we have this yet? I don't think I do. Something like this would be very nice. I actually want to have this. Let's improve our, it's the wrong one, but let's improve the scripting language and allow this kind of thing here. It's always fun to improve the scripting language. Here are all the test cases. Where do we test function definitions? Here. Okay. Function definition with parameter explicit parameter type. Def x int x plus 1. f of 5 should be 6. That's our test case there. And it should fail to compile. And we should fix that right now. Here. Somewhere we're parsing function definitions. Yes, that's here. There. And yeah, very simple. It just goes through the code and expects an identifier, one identifier next to the other, like in a normal function definition. Identifier, identifier, identifier. But now we also allow types. Here. Parse colon type. Yeah, let's say parse colon type opt for optional. Error as expected, and now the error should disappear. The type is not actually tested at runtime, but at least it's already declared. Oh, but we can do what? What? I must have made a mistake. Parse type. Parse colon type. Yeah, this one looks correct. Oh, what did I do? I put the wrong one here. This one. And actually we could maybe, yeah, we could record the type that was given to improve the autocomplete, because now if I say img, okay, it's a compile error, but I wouldn't get proper suggestions here. But if I pass this type to the autocompleter, it will actually give us correct suggestions. And we just need a little bit of a change here. Actually like this, to keep this type information. Yes. Now it's not only a list; it is also, yeah. What's done with these arguments? Let's see. We parse it somewhere. Parse it somewhere. Pass it. We pass the value somewhere. Okay. So we could keep the list and also make a map, or we make a map which is also a list, which is like my favorite smart thing to do. New linked hash map. Argument names and types. Type. Yeah, let's make a function for it to type true value descriptor. Because this value descriptor is more general than knowing the type of an object. It knows if the object can be null, and it knows if the type is precise, meaning if it can be a subclass or not a subclass, and it can even know the exact value of an object. So it's more than just giving a type. So that's why we have this conversion type. And this type class is just a Java representation of a type, which can be a class or a parameterized type. And if we have no type information at all, we just say new value descriptor, which is like an empty descriptor that knows nothing. And this can be null, which we assume defaulting to true, but here we have to pass it on. Okay, this should not have changed the code. There. And yes, now we say type to value descriptor. If there was no type given, we just say default, and we put it inside our map. This will work, and here, in fact, we should also store this in the compiled result. Yeah, right now this function def only knows argument names. We'll change that at a later point. So, there. Now the test case should work, and we should get this autocomplete. Play compilation music here. Music while compiling. Error, okay, yeah, because the code doesn't compile as it is. Type to could be better. I'm not sure if I fixed all the bugs. What is this one here? Type boolean is undefined. But I literally didn't change that. Okay, let's check. Yes, value descriptor. Non-exact C. Oh, it takes class and not type. Yes, 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 yes. Okay. We have this helper method, which is I was actually. Yes. No. Whatever. Hey. Okay, I think that was the fix. The original thinning algorithm I made is too complicated. I think it has different phases. It has 2 different phases, and has these little fixers that fix certain cases that where the structure was split in half while thinning. If this new approach works, then we will have a very simple and elegant and probably performant thinning algorithm. Okay, all the tests run again. And here we should now get our proper autocomplete, although we don't actually. No, it does not seem we get that. Too bad, I was hoping for that. I'll fix that some other time. Either way, we have our bit or. This sets our flag. Okay, so or pixel image 2. What were our flags? Possibly black. This flag definitely white. Yeah, let's give it some names. Def white. 28, 6, pos black. Possibly black. Yeah, whatever. Possibly black. Def white. Oh, what's with the autocomplete today? Come on. Actually, the same thing with the other one. Possibly black. Autocomplete is not making me happy today. And the other one is actually the same. Now it gets very elegant. Same thing with a different flag. Okay. I think the double thinning doesn't really make sense yet. But okay. It's not get pixel, it's like get int pixel, I think. No, it's not. It's get int. No, it's not. What the heck? Okay, actually this was wrong. Okay, it's all white now. That's not the right thing. Am I using the wrong method? Get int. Get int. And set pixel. Okay, it's called set int. These few function names are not terribly good. Okay, that's more like it. So, yeah, okay, we have so these bright ones are known white and possibly black. In the middle there is wait. No. Definitely white, and in the middle we have no white. I'm a little confused right now. Oh, higher number means darker. Okay, the darkest, yes, the outside is 192. The outside is, no, wait. What? No, I'm still confused. We should visualize this better, I'm sure. There are no unknowns, that's for sure. This is kind of a useless state. No pixel will be unknown because we go through all the pixels and each of them receives some flag. Oh, of course I mixed this up. That's the confusion here. Right. So in the middle is this possibly zero will not occur. So these dark ones are possibly black. All around here we have definitely white, and this very bright stuff is the unknown area. So in this step, if we just take the darkest color, we have the correct result. So let's do that. To B. And we can pass the threshold, right? Yes, we can. And the threshold is greater or equals. Just a short comment. So if our threshold is 128, we shall get our result. So that works fine for step 1, but what about step 2? Thinning again. Yeah, okay. So the outside is easy, the inside is easy, this top line and the bottom line is easy. Left and right, they are not that easy. And situation is, both of these pixels are marked possibly black and definitely white. So in this situation, actually we just have to choose one of them to be black. And I think we should choose the left one, because that keeps things in place. If we choose the other one, we will have an image that is moving slowly to the right. We can try both of these, but yeah, so the special situation we have, which we did not have in the first image, all good. Here we didn't have two of these bright pixels next to each other, but now we have this. So if we take the threshold approach, it fails. Which means we do something slightly more complicated. We make an image through a function, image from fonction, l'image, la fonction, image to be from function, because we want a binary image, width and height, and that's our function. Our input was image 3. Get pixel xy. Okay, let's say get int flags. So we only handle this special case, otherwise we do the old threshold thing. Yep. If flags is this, and pixel right next to it. Oh yeah, what about our out of bounds checking? Get int. Right. Oh, this image actually has a border color that we can define. I actually don't want that. I want to specify it explicitly. Yeah, let's put that in. Int default. Let's put it down here. Or is it actually, maybe it exists in the interface? Yes, no. No, it does not, but it should, whatever. What happened there? A mouse slip. Okay. Value in range this, then this. Otherwise, default value, that was pretty easy. But we have to recompile everything once again. I can keep coding though. If This is 129, and this is also 129. Then we do our special case, which is just returning true. No, returning false for black. Yes. Else we do the threshold, which is black's I don't even have greater than or equals. Huh. That's something worth adding. Greater equals. Yeah, no, I don't see that. Greater or equals. In short. Greater or equal. There. And there. And trying to convince the program to add the function. Wait. Greater or equals. Yes, there we go. There we go. Wait. Yeah, it has to work because it worked before. Threshold 128 is the thing that works. Yes. We did it here before. Yeah, okay. Else and some brackets and bam. Okay. That's not entirely bad. I mean, it looks asymmetric, but it's... who's to say that the result of this function should be symmetric? You know. Yeah, I mean, what is more correct, this corner on the left or the corner on the right? And it may turn out that neither of these is more correct because we are working with outside of the assumption that this is a result of growing. So yeah, actually, I mean, that was this, so wait. Wait. Oh yeah, okay, I see. So out of these vertical strips, it shows the left pixel to be black, which is why the square looks that way afterwards. This one is just to the left of this upper line, and here it's a proper fit, so that's why we got that result. We could we have two ways. We could use the inner one at both cases, but why? Like locally, these two look exactly the same. So there's not a reason to choose the right one here and the left one here, I think. We basically have to live with this little asymmetry, but it is probably not a problem. We can do some more post-processing and actually just delete these pixels. Also, I think this is alright, basically. It does not destroy the integrity of the input image. Yeah, right, okay, so actually, turn this into a function also. Def post, or let's say finalize the image. Add some nice types here. So cool. Change this, change that, and test it out while the file lies. Yeah, the autocomplete is really lacking. It doesn't even suggest the function name here. There we are, same result, which is what I wanted. And then we can also call the finalize function here. No change either, that's all good. And if we do it all again, one last time, 4, 3, wait, there should be B here. Now we have a break, but I think I probably did something wrong here. Let's show all of them. Image 2, image 2B, image 3, image 3B. Image 3. Wait, no. Image 4. Okay, now we introduced some hole here. That's actually not acceptable. Let's see why that is and why it let's see whether it breaks our approach or not. Maybe we just change the logic a little bit. Here we had these bright pixels only next to a dark pixel, which led us to choose the dark pixel. In the next one, we have these two bright pixels next to each other, but when we just chose either one of them, and it was fine. This time we have two bright pixels next to each other, but also we have a single bright pixel here. And yeah, okay. In fact, we may have to stop the thinning when we're getting to 2 pixels wide. That's kind of the thinnest we can get, because if we look just at the local area here, we don't know what's happening at the top. Or I mean, we have to find some way to keep this 1 pixel up here black, so it doesn't break the structure apart. Here it's okay because it's a little different, but here we need to keep this 1 pixel. So how do we find out that we have to keep it? 2120 is the coordinate. So 2020, 2120. Yeah, it used to be, it was black before, right? Yeah, 2020, 21, yes. It was a black pixel. Okay, it's sadly not as trivial as I had hoped. Maybe we can salvage it. Yeah, that's it. this and this. Okay. Let's go step by step again. Here. Yeah, see, now this step we just keep these 2 pixels wide because we don't really know what to do. Interestingly, it is getting... Oh, that's interesting. It does get thinned in the next step. Oh, that's funny. Okay. Maybe I actually fix the whole thing right now. Image 4 is this, which looks very pleasing. And 4b is a very nice symmetrical square. That's actually excellent. Let's go one further. What about image 5? Oh no, it gets thicker again. I mean, that's really... I'm tempted to say the plot thickens. Any typos? Nope. So, I mean, I do one more step. I get yet another structure. Oh my god. Okay, now it's losing structure again. Yeah, but why is that? Let's see. Image 5. This is an okay. This is not great, but okay. Maybe the whole thing is not as cool as I thought it would be. It's kind of disappointing. It's so funny that it goes back to width 2 again. Maybe I hoped for too much with this new algorithm. Or maybe we have to do all the directions, like all 4 directions at once. Maybe then there's a way to salvage this. So can we narrow down, can we describe the problem? What is the problem that makes this not working? We go from start again. Here. Yeah, maybe the algorithm is just not smart enough. In order to keep the structure together, it has to look at all 4 directions, not only left and right. There's just no way to do it properly with just looking at 2 pixels at a time. We have to look like at a 3 times 3 neighborhood of pixels. I think that is the takeaway here. Thinning by looking at pixels at a time. Spike. Probably unworkable. Devastating result. But every experiment yields some knowledge. So the knowledge is it's not possible like this. But maybe in a different way. What's the time? 1 hour and 15 minutes. And we'll move on to the next step. Next thing on the list. That's my verdict. Track regions in the webcam. Yeah, because that will be an actual feature. Actual image recognition thing. Okay, let's go to some suitable project. Do I have a suitable project? Oh yeah, the webcam problem. There's one Java process that has the webcam image, and I want to process the webcam image in another process. I looked into ways to exchange data between Java processes, and there are basically 2. One is having a memory mapped file that one process reads and the other writes. Disadvantage is that every image you save there will be saved on disk, essentially even though we don't actually need it. We just use the file as a transfer mechanism, and it all happens in the memory in the cache. But it will still occasionally write this to a disk, however the operating system sees fit, which is probably at least once a second. So we write the stream of images to the disk, but overwrite them instantly, which is bad for like SSDs. It's like a solution that's almost great, but well, although it should be very efficient, especially if you have multiple reader processes. It's just basically it just is a memory access. There's not even copying, basically. You just access a memory region. It should be super efficient. You should do this in a RAM disk, but I don't think there's a way to make a RAM disk on every operating system. Create RAM disk in Java. What is going to show now? Yeah, there's no API, I know. Yeah, memory mapped files, exactly. What do you mean .NET? How do I call .NET from Java? What the what? Okay, for it's a German production. They actually want me to execute a format command from inside Java, because you're formatting the RAM disk, which should not be a problem, but I mean that seems so dangerous to actually create a format command and issue it from your Java program. That's like super unsafe. Okay, they actually didn't say Java. Oh, okay, my bad. Okay, they're telling me there is a Windows command to make a RAM disk. We could do this, I mean, theoretically. Do one mode for Ubuntu. On Linux is actually pretty easy to make a RAM disk, I think. Windows. Mac OS, I don't know. Yeah, this seems complicated and requires permissions and what have you. The other way is to use a socket, plain old sockets. It's definitely less expensive, less efficient, and you need to assign a port, but it's fairly straightforward. Yeah, well, I mean, we don't need high frame rate for now. We could actually just save one image in this file at a time. We need to synchronize things though. Yeah, there's some stuff to figure out. And we could basically just create an image file on disk and delete the old file after a little bit. Keep just a few of them around. Or we do the socket interface. That needs some programming. So I'm super thrilled with all these options. None of them are very elegant. I have some functions for making a socket interface. They are just converting everything to text. So if you want to transmit an image, you have to convert it to some text. Like base 64 encoding. I mean, basically I have something like that. Start dialog server. And it's supposed to be pretty elegant. Dialog handler is our interface. This is very old Java Xcode, but old doesn't have to mean it's bad. Ask and ask loudly. Let's test this one out. So we have the webcam stuff running in this Gazelle instance. And what if I just say start dialog server? It's actually built into the program already. What are our options here? Just a port and a handler. Okay, port is 5050. Random port. And let's say we put it in the project variable. Server. So we can stop the server again. Handler. How does that work again? Okay, it just has one function. That's very nice. Handler. We get this IO object, and I can just say read line, and then answer something. So something like this, while is still connected, line, read line, and as a check, let's just say OK or something. Send line OK. OK, and whatever the person said. Huh. Unknown weight, but I created this variable right there. What did I do wrong? Oh, dialog handler is not a single method interface. Oh, it's an abstract class. I mean, that's fucking bad design, sorry. That's bad design. You can make a breaking change here. Oh, ouch. Oh, ouchie, ouchie. Dialog handler. Maybe we can make it such that is not a breaking change. I think it's a good idea. Here. Can we? Yes, we can, I think. It's already open. Dialog handler. So we change this one and make it an interface. Yeah, okay. Oops. There, and yes, it's still kind of a breaking change, but it's still that's our interface. And we just add this to our list classes. Load. 1001065. Computer working hard. Oh, it's restarting Gazelle. Kind of prematurely. Dialog. Okay, it's in there. Now you can recompile. No, you cannot. I have to make the whole thing. Ouch. Okay. Yeah, this should give us a little server on a port. Which we can actually test in telnet. Good old telnet. Telnet localhost 5050. Not running yet, but it will run soon. Yeah, still compiling. Time for more smoothie. This is pretty excellent, I have to say. Okay. This Gazelle we have to restart manually, because every time we do the webcam disappears, which is why I don't auto-update that process. Nothing to update. Is that right or wrong? I don't know. Let's see what this here says. Okay. Yeah, but no. What? Oops. Put it in there. I just put it in there. Yeah. Huh? It is in there. Where is it? What? 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 I know I'm repeating myself. All I can think is what? Unknown object dialog handler. I am not getting this. Oh, I do need the repackage thing, I guess. Yep, I think that was it. Yeah. Bye once again. See you in 3 seconds. 3, 2, 1. Okay, bit more than 3 seconds. Okay, here we go. Set project var. Set transit project var. Can start dialog server on port 5050. Yeah, in fact, it was already started, but not saved, so we can't stop it again. But now that should be fixed. Run. And now we have a dialog server variable here. Why is the value null? What's that? Oh, what? It's not returning an object. Oh, that's mildly lame. Oh, there's not an actual object representing the server. It's this conglomerate of objects. There's some different way to stop the servers. Yeah, I'm not totally happy with this one. Wait, how do you stop them? What? What? It looks like there's no way to stop the server once it's started. What on earth is... Oh, it's this ugly thing where you have to grab it from a variable afterwards. Yeah, okay, that's mega uncool, but... I guess it was my old programming style back when I was in my first 1000 scripts. Well, today I would make this in a more object-oriented, more elegant way. So in fact we have to... Yeah, maybe there's a function that does this. Start dialog server. Yeah, there was something. A class was called Android 3. Aha, you wrapped this. Okay. Aha. Okay, that's a little. Maybe that's the one we want. It's a proper class and everything. Oh, we have this responder thing, which once again is a class, not an object. Not an interface, sorry. Responder. Yeah, but we can still work with this simple version that we have here. Let's just make it work. There. And I think it returns false if it failed. It's a really old code with like an old kind of style. Fail can't start server at port. Port. And yep, because it's already started. Last restart, hopefully. Well, probably not. Restarts and reboots. Every programmer's daily bread. Let's try again. No pointer exception. Oh, this one is not... okay, this one fails actually. I don't even have to do this. It fails when it can't do that. But I can get the variable first. I can stop the old server first. Old server, which is a service socket. Yes. I can actually close the old server. Close old server. Start a new server. Okay. If it's not null, then because it. Oh, hi. Because it's more fun to program, and sometimes it's interesting to watch. And also I have students, or I used to have students right now. Well, I actually have 2 interns still. I could make them watch this. Yeah, it's my way to motivate myself. And the interns usually like it, actually. Sometimes it's tough stuff, hardcore programming stuff. Sometimes it's very entertaining. This one seems to return null. Oh man. I can use this function, which should be better. I'm here trying to do this here. Sound like criticism. Why are you doing this? I'm not trying to hurt anyone with this stream, I promise. I basically want to get to the point with the project. Oh, let's put a link here. I want to get to the point with the project where it actually does very impressive things, like image recognition and video recognition. And just in order to get there, I have to do some coding work, which is sometimes tough. Spawner. And sometimes I get nervous when I know I have people watching. I should make the interns watch again. One internship just ended. There are Indian interns from the NIST. Super lovely people. They're like early in their studies, but they're very busy. Like they have college like every day, like 6 days. And on day 7, guess what they do? They have to do homework for college. And in the evenings they do sessions with me, like what we call an internship. It's pretty nuts. Okay, let's turn this into an interface, because that's easier to handle. Spawner. And actually, I think we should be able to make our socket server fairly easy, like this. Multi-port. Yeah, there are some things to configure, but no problem. Okay, socket server attempt using this. Now we use this one, which is called responder, and we get an input line, and we get a history, which we don't need, I think. This loop is done automatically, and we can just return any kind of answer. For example, just our OK response. Yep. And do this here. Something like Android. See. Android 3, what a name. Why is it called Android? Because it's a server that responds to text input through a socket or something, and I called that an Android. It's not worse than the name Android for a phone operating system, which I never liked. Like the name Android it's a phone, it's not an Android. An Android has legs. A phone doesn't have legs. I mean, the phone can speak, like, I mean, Alexa and Siri and Google, what's it called? See, Google's voice assistant doesn't even have a memorable name. It's called OK Google, right? Google Assistant is called Google Assistant. So Google Assistant is kind of humanoid, okay, but the phone is not an Android. So I claim it's a misnomer. Unknown object I responder, but come on, now we should be very close. Oh, we have to restart here. Okay. Still unknown object. Why? Okay, the interface is there. Come on. For real? Did I save this? Yes, I saved this. No. Wait. Yes. No. No. I wanted the other one. I make all my own build systems and everything too. I'm really kind of freakishly independent in terms of my tools. So it's in this one. My own Java extension, my own build system, etc., etc. My own scripting language. This is my Java-based scripting language, which has a very different syntax, though. Okay. I want this to work now. Come on. This stuff will also change. We have set the port and disable this thing here. Something like this, I think. Is it at least closable? Is all closable? Yes, fantastic. Unknown object I responder. Are you kidding me? Maybe I just have to do this, but no. Oh man. We set the responder, responder. Nothing to update. It's driving me nuts. It's not finding this one interface. Unknown object. This is haunting me. Unknown object. Unknown object. What the heck? Ah, it has deleted the import, but that doesn't really matter. So the interface definitely is in the code. Right here. It's in the package. Loadable utils. It's finding this one. It's not finding this one, even though they are declared the absolute same way. I mean, come on. I mean, I'm losing faith here in whatever. Oh, that looks very amazing. Directory called quote. Oh, now it's finding it. I don't know, I had to do like click buttons 3 times. Okay, never mind. No, no, it's not working again. Oh, Jesus Christ. Let's check the Java file. It's there. Definitely. Okay. Okay. Use multiports like this. I think use multiports maybe. Okay. And I can give the bot a name, a greeting actually. These socket bots have a greeting. Greeting. Webcam image server. Let's go to telnet and check out our cool server. Telnet localhost 5050. No. No, no. Telnet server. It doesn't seem like it's starting properly. What do we have here? It always decides on its own port, but you can tell it which port to start the search at. So we start at port 50. Better, vport 0, okay, but is it on the actual port? It is, see? Wow, webcam image server, UID, whatever. Hello? And it says, okay, hello, yeah! Okay, that's our socket server. Wow. I'm totally flashed. Closing the old server, starting a new one. Let's try that. Boom. This message here could be better. The code word is buy to get out of it. Buy stranger. Very cool. Okay, so now we can serve something. For example, just get latest image. By default, we say didn't understand. If latest image, we return a base 64 encoding. Maybe you could get around that, but for now, let's do it text-based base encode. Yeah, where's our webcam image? I think. Yes, we have the variable webcam in the project. So project var webcam with a space. No. Image. Yeah. Which format do we use? I mean, converting to PNG and back just to send it over a socket is like pretty ludicrous. But we can't really transmit the raw image data without some size information. So pixels of buffered image. This is an array. This should be an int array. I am pretty sure. Yes, but we actually need a byte array. Now this is not efficient yet, but int array. Length. Okay, the last int can be shorter. Int 2 bytes in array little. Okay, let's use this one. Okay, if there's no image at all, we return no image. Else we do some fancy stuff here. Let's say take the width of the image and the height just as an integer string. This is horribly inefficient right now. First the width, the height, and then all our pixels. Add the function, and maybe we have our image server. Okay. If only I had more cores. I should make some cool image recognition, sell it to a lot of people, and then I can buy a computer with more cores for streaming. life plan. Also keep crypto trading. I actually think I might have a crypto trading algorithm that works. Why is it still running? Oh, because I have to restart it manually. It always takes away the webcam, but can't change that for now. Yeah, I made 6% on Monero in 5 days. That was encouraging. I'm not using anything fancy, just Kraken. Just a regular exchange. Alright, start again. Latest image. Okay. String cannot be cast to Boolean. String cannot be cast to Boolean. Oh, if. All right. Yes. I'm not liking this message vport 0. Vports are like something I made up, shared a virtual port within an actual TCP port. So this function should just give us the actual port that we are on. So let's see, port here. Report port or port comma report. Yeah, if it exists, report 0, nothing otherwise. This plus this and this and this and this and that, and boom. Yes, that was just cosmetic. Latest image. No image. What do you mean no image? I see the image right there. No image, kidding me? So webcam is this object. If we do it, we definitely have an image. Oh, okay. If it's null, then no image, of course. Restart by reconnect. It should kick out all the clients when I restart. Yeah, restart the server. It just kicks them out, or even transfer them to the new server. Latest image didn't understand. I see. Okay, we have to return the value. Bye and hello, latest image. And there's our image. That's the base 64 encoding of my face and the rest of the image. That's pretty neat, actually. How fancy computers are, they can scan all this data so quickly. Latest image, width and height, and here's our stuff. And the slashes are up because there's no alpha channel, like no transparency channel. We're wasting like 1 byte per pixel for the non-existent transparency channel. But that aside, it's actually cool. Okay, let's react to this line here. If equal line cool, say thanks. Cool, thanks. Yeah, nice. Okay, so now we can actually grab the webcam image from other processes. Start webcam image socket server on port 5050. And in fact, we can just say run on project open, and it will run when we start the project. Yeah, open the project. Let's test that quickly. And here I broke stuff. Let's fix that quickly. Yes. One more change. Now this compiles again. Okay, so now we have to make the other side where we base64 decode our image such that we can recognize it, analyze it, do stuff with it. Is the server auto-started? Yes, it is. Cool. Bye. Okay. And opening a connection to such a server is done using the function talk_to. I was already into fancy names back then. Talk_to and just a port, and you get this dialog IO object that you can use. It's definitely already compiled in. Yes, it is. We just need to import. No, we don't even have to import. We can just use it, I think. So now we go to the other process here. It warrants making a new project. Grab webcam image, or whatever. Here. Port is 5050, talk_to ports, and we have an auto close. This closes the thing after the script runs. IO send cool. Ask is I think the function. IO ask cool, and it should say thanks. Oh, that doesn't work. Assignment plus temp. It would probably work like this. No, like this. No. It would work like this and like this, but I want a combination of these. So it's another extension of our scripting language. The cool thing about me making everything myself is I can adapt things very easily. Temp add. Okay. Temp combined with assignment variable declaration. Temp assert instance of something like this should be enough of a test case. There. Then we see the test fail according to test first coding, and then we make it not fail. So here we parse an expression after the temp, and we actually want to parse an optional assignment. I think that's all that we need to do. Change this into assignment or expression that could actually do the trick. Yes, no. Oh, I ran this before I made the new code, so running it again should now succeed. Yeah, so this process has asked the other process through a socket, and it said cool, and the server, the other process answered thanks. So there we go. This test case also works now, so we can shorten this to that after it has rebooted. And instead of just saying cool, we can actually get the image. And after a bit of decoding, we will have our webcam image. Yep, it's a very long string. It is actually 1.2 million characters. So then we how do we parse this? Make an actual regular expression maybe. Oh well. No, I mean we can do simpler stuff. Split at space sounds good. Parts. So we have 4 results: image, width, height, and the actual pixels. Assert equals first part image. First part, yeah, first parts. Width is the integer in there. Height is the integer there. Base 64. Pixels is this one. And we do base 64 decode. Is pixel bytes. And we convert to ints. Which we don't have the function for. Int byte int array. Int list to byte array, int array to bytes, int bytes to int to bytes, byte array to int array. To int. But don't tell me we don't have this. Int from bytes array. Int array from bytes. Okay. Int array from bytes, little endian pixel bytes. That gives us pixel ints. And from the pixel ints, we can finally construct an actual image. I think like this. So this is the native resolution of a webcam, I think. 64 times 360. We could scale it down to, but why not use a native resolution? Get all the pixels we can get. Base 64 decode. Yes, it does need an argument. Okay, nice. So the time is 260 milliseconds, but it's including it's including connecting through the port in the first place. What if we check the time for the actual communication? Like this. So that comes down to 150 milliseconds. Yeah, 100 milliseconds. Something like that. It's not exactly fast. I mean, there's room for improvement. But for now, we can work with that. So the idea is to distribute the image to all other processes that we want, and even through the network. If we have another machine next to this, we can transmit the image through the network. Okay, grab webcam image. Boom. That's pretty good. So now I can restart this project, process all I want without affecting. I can't even speak anymore. Without affecting this process here, which is supposed to run all the time. So we can look at the great webcam. Okay, so boom, done. Can we now actually do some image tracking? I wanted to track these yellow things here, which are my headphones because they stick out so nicely. So I am getting tired, but this is tempting. Let's see what we have done there already. Was it here? No. Yeah, finding things in between projects could be improved. Where could I have put this? Fonts to meshes, no. Possibly on the server. Crypto, oh yeah. I do my crypto profit calculations in Gazelle. It's for another video. On-screen keyboard, very cool, thinning. I actually don't remember where I put this. Which is unfortunate. Yeah, I definitely should make a little UI thing for that. Yeah, let's do that. Yep. Networks from all DBs. Just to find things among all the projects you may have. Networks from all. Nowadays we call them projects, not databases. Important distinction. Buttons we actually don't have right now. So there's that. helper methods. That we also don't need. Neither this. It's using the default table rendering, I think. Yeah. Was it description? Description, yes. Okay, put this in the program. After we fix it, okay. There. And some little syntax problem. Oh yes, my bad. I can't seem to fix this Java syntax. I should take a Java 101 course. How about we just delete all this stuff here? See, it looks much better now. I could make these windows always on top. Actually, I guess that's a good idea. Okay. Last little bug. Yeah, let's make these windows always on top. Where is it? Here. Always on top. Oh, this never worked, did it? On window closing with no frame argument. It's ridiculous. Why did it even compile? Well. Is it always on top now? Yes, it is. And let's do the same thing with the other window. Always on top. Frame. Save. Run. There it is. Boom. And let me fix the bug. Oh, the chat is sometimes hidden. Can I fix that? Chat, always on top. No. This chat window is super cool. OBS just gives us this YouTube chat window by default now. I'm super happy, but it cannot be made always on top, I guess. At least I don't see that here. In fact, the window is not even visible on the taskbar. Special kind of secret window. Okay, the point was... Where's my new entry? Oh, I gave it the same name as the other one. Of course, that will not work. Networks from all projects. Those databases are now called projects. Hope you got the memo. One more compile. Yeah, in fact, this is it. The list is empty. Empty is bad. No, it's just, it was loading. Okay. Sure, go, okay. These are all the networks we made. Networks are the recognition workhorses of Gazelle. One of the gazillion terms I invented for this project. Yes, it was renamed. There, it's loading. It should show loading animation. That's okay. There. How bright is a random image? That was a fun little network. Showing it is to do, but I think I can just show it normally. And here we have a network which does a brightness threshold and then tries to detect some letters. Because this one should be the one with more information in it. Let's quickly try to actually show the network. It's actually super easy. Let me just do this here. Make detail view. Finding things is not so hard. We do like just an optical thing where we look for regions of the same color and call that a region. That's like the starting point or center point in any image recognition. It's not the starting point, but it's fairly close to the beginning of the recognition. First we do a bit of color manipulation and scaling down maybe, and then we do these regions of the same color. Then we can do some post-processing of the regions, and then we can do like animation checks, like to try to track the region among frames of the stream. And we have different ways of doing that, of linking a region in one image to a region in the next image. For example, color or shape or position or a combination of these. Yeah, that's cool. That's my network system. It's actually fully functional even. There's some error here, but it's because I think... Yeah, why is that actually? Because we simply have no image. It should be handled more gracefully, I'll give you that. Where is it taking the image from? What is... Oh, come on. Yeah, this should yeah, layout problem. Okay, here. That's our code in here. And yeah, basically this network is in a foreign project. We always have a project open, which is indicated here and here in the title. And now we are showing something from another project, which is not properly loaded, if you will. I guess that's the main reason why this fails here. It shouldn't really fail, but we'll have to figure it out. We can see the data flow, typical Gazelle data flow. There's an image in the left here, as we start with. They all say error now, but so there's a downscale of the image in this case because we have some big photos in this project. Yeah, let's open the project and show this properly. Oh, we have a button for that. Yes, no, I have a button here. Open project, yes. How elegant. Yeah, this is an actual dataset with actual real-world photos with text in them, which I'm not showing because I imported them badly from the server. Okay, that must have been the problem. This project was not imported properly. Yeah, so but we do some post-processing, we convert it to black and white, and we do these regions, and we do the meshes next. Meshes are something like the stuff down here, where you have all the endpoints and intersection points marked. And then we can work on that further. For the regions, we're not going to do that. I just wanted to steal some code here. Yeah, let's do it step by step. So many images, so many frames, I mean. Grab webcam image. Well, this project we can consider done, I guess. Let's start a new one. Track objects in webcam. So let's get to the actual stuff we want to do. Copy this one script over here. There, run. There's our webcam image. And now we make a network to analyze the image stream. This should be some kind of function to call. It is actually. You can just call this script using the ID 8. Okay. Object tracking test. Okay. You can actually just put scripting code inside of these network elements. In fact, we can simply calculate something. Oh yeah, we want to call the script. Call script ID 8. There's our image. We just have to give it some port connections. I want to automate this, but right now I'll just continue like this. configure. Oh, it froze. That's fresh. Why does it? How does this freeze? Oh no, it's the error is on the other screen. Okay. Okay. Delete, no, delete ports. Make sure errors appear on the right screen. Configure. Use our output ports. Output ports are green. So to here we can connect our processing nodes. I like this one here. Let's save it. Smiling PNG. And yeah, this effort should be reduced, this configuration effort for a node. Because basically we are calculating something, it has a return type, we can just use this type as the output type and that's it. Why do I have to specify the port explicitly? That's kind of ridiculous. Let's do everything in one go this time. We can definitely steal a little bit of code somewhere. Yeah, this layout here is not the best yet. Let's do a quick fix here. This is too painful. Element. Side. Yes. Ellipsible left panel. I basically want three views: a view with just the content, a view with just the code, a view with code and content. We can do a quick hack here, I think. Min size and min width 0. Just to allow this split bar to move all the way to the right. Right now it's stuck here. Both of the sides are claiming a minimum size. So I can't move this separator here. Can't see all the code. And I hope I just fixed that. Smoothies for smooth coding. Smooth talking, etc. Computer working hard. It's a ThinkPad, it's very nice, but it only has 4 cores, so it's not the most powerful computer in the world. Okay, that actually worked. I can move it all the way to the right. Not really to the left, but I can do it like this. But I guess we can do it the same thing on the left too. Minimum width 0. Let's just write image param. Okay. we get an image as input. We say scale and posterize. Image with a number of colors, which we can set. Let's set it to 4. This actually means means 4 grayscale levels. Recognition is operating on grayscale normally. We need the configuration again, which I want to optimize, as said. Add input port image. I can almost write this by heart now. I can't write it by heart. Input port and output port. Output port regions, which is some kind of list. Let's say we output downwards, like that. Configure. There's our input port, output port. We can say magnetic connections, and these two networks, these two elements are connected. And we calculate, and we get a posterized image. Every time we run this one here, it will update here also. In fact, though, I want more colors for this specific demonstration. Let's say 8, because then the headphones stick out more. They actually have a different color than, like my head, for example. So it should allow us to track them more easily. We're still aiming for the low-hanging fruit here. What? There's a delay in the webcam image. No, it's gone. There was a delay a moment ago. That was funny. How is that possible? I don't know. I guess it is possible, because the new images pile up if they're not processed quick enough. They're not actually being dropped. I guess they should be dropped. I mean, it's a question, but let's see where this happens. Show webcam window. Webcam image obtained listener. Set image. Is it stacking up? Let's see. Is it waiting for anything? I don't actually think it is stacking up in any way. It just saves the image in the image surface and says repaint, but repaint is asynchronous. The size is not changing. This is not executed. Repaint is just repaint. I actually think it should not be stacked up, but it looked like that a moment ago. Like I saw my movements from 2 seconds earlier. Well, I have to check that out later. Posterized, and Yeah, let's do two steps. First we do scale and posterize, so we can watch the results. In fact, this will output a black and white image. Here we take the black and white image and make our regions as in this project. Nope. Oh, it's freezing again. And now it's, yeah, replaying the images. The thing is, if you keep a lot of images stacked like in the queue, it will take quite some memory. Here we are throwing away regions which are too big. Yeah, let's keep that in for a moment. In fact, this one I liked already. Like it was here. There's this, there's that. Configure, connect. Hey, connect. Okay, it found 2,572 different color regions all over the image. And now the interesting thing comes when this makes me crazy. This delay and repaint. I have to figure out why this is happening. I don't completely get it actually. Anyways, yeah, we take one image and we take the next image in the stream and see which region may have moved where. Yeah, that's basically our plan. So it's, in addition to one image, we need multiple images. And do this twice. Basically, we want a cool architecture where one node here can have multiple instances at the same time. Like this node that makes the black and white image and the other node that makes these regions. They have to work on multiple images at the same time, and the structure should handle this like as automatically as possible. I call this multitude, I think. It can also apply to having different assumptions, different hypotheses about the image pursued at the same time. So with different assumptions about the image, you get different processing results, and in the end they can be recombined. The best one is chosen. So, but I don't have that architecture yet. So I would have to make this node, like a copy of this node. It's not very elegant. I'm probably getting tired anyway, so we are not getting to the proper result. We could do something nice and simple, like just show the brightest regions, just to have something, some visual result. How about that? Show brightest regions. We only have 8 grayscale levels, so there's a definite definition of brightest region, which is not only one region, but probably multiple regions. Regions is a list of on the image region. Input port regions list on the right. Output port is nothing at this time. And we have to find out what the brightest color is. Regions. Get the brightness, and we get the maximum value of that. Max brightness. Configure me. Oh, let's move this one port around. There, connect. And calculate. Okay, yeah. Maximum brightness is white. So headphones are actually white after converting and after posterizing. That's nice. And we filter the regions where we only take those which have maximum brightness, which reduces our region list to 31. Brightest image regions. And in a separate step we can actually show them as an image again. Because this list of numbers here is not terribly easy to read for humans. New node. Show regions. This node will need an output port, which is called filtered regions. It doesn't really matter what it's called. There. Yeah, we just make like a black image and show all our regions in white. Is there a quick way to do this? All region. Don't really. Region to black white image is almost the right thing. Yeah, I think that's our guy. Let's just optimize this, makes it more flexible. In this case we don't even need it, but settable, and color is white. And in fact we leave the color when it's not in the region. This draws only one region. I mean, whatever. Let's do it manually. Okay. For region in regions, image is new black image in width and height. Width and height we can get from the regions, but if there are no regions, we don't know. If empty regions, black image, just make it a small image. Otherwise, we make an image. We get the size from first region. That's our size. We make a black image. We go through all the regions. We go through the points in each region, and we just draw the point. Black image. Made like this, and we return image, and we add this little function here. Oh, I didn't even need this. Why did I? Oh, okay, here. Whatever. One needless restart later. I want my 8-core. 4-core is not cutting it anymore. Come on, you can do it. There's a 1 second delay between the calculations of each of these nodes. That's why it appears a little slow. I put it in so we can see the data flow more easily. Of course, you can reduce the delay to like 0. Configure. Okay, it's like on the wrong side here. Configure. There. And connect. There. And calculate. Nope. Okay, we have 0 regions here. How's that? I mean, if you take the brightest regions out of 2000 something, it's definitely not going to be 0 regions. Okay. I don't know why I had to recalculate that. That does not seem right. What about this one? Size 18 we have there. Yeah, I'm just doing something wrong here, I'm sure. Oh, error, okay. I have to show the error in place here. Get image not found in... Okay. It's called image, I think. This is called image. Point iterator, not found. Pixel iterator, yeah. Major difference. Okay, set pixel not found, now we're close. Okay, it doesn't take a point object. We can change that. In fact, set int is what we wanted. Point p. Oh, check that out. So it's not updating the image automatically. But once it does, the change propagates through the network. We go here. So we got at least one of the headphone ear things. Okay. So we could track this right thing here fairly easily by going to another image and then seeing where this bright thing moves. But I'm pretty tired, and how long did I do this for? Yeah, exactly 3 hours. When I work with my students, it's normally a 3-hour session, so that's perfect. Hope you tune in tomorrow, and it's a PP buy the product, which you can't do yet. You can pre-order your personal image recognizer. Bye bye everyone. Thanks to Peter for